Hello, this is Infinite Engineering, and today I'm going to do an overview of my wet cell hydrogen generator. So this is just going to be a basic overview. I'm not going to be doing any, I'm not going to power up the generator or anything, just because I don't have the power source at the moment to fire it up. But I'm just going to do a quick overview of just the basic components of a HHO generator, and just show you guys exactly what it's all about and how I built mine and how I got inspiration for mine. So I based my HHO generator off of Grant Thompson's The King of Random, his generator that he showed on his channel. I really liked his design with the PVC and the acrylic tubing that you can see here on the front, and I thought that was a really neat design, and I wanted to kind of incorporate that into how I built mine. So if you look at the plates in this generator, you can see I think there's 12 plates. There's a couple neutral plates here. These two inner ones, the two inner plates here, are either positive or negative, depending on how you hook up to the terminals, and then the two outer plates are the positive or neutral. So there's the negative plates in between, and then you got your positive and negative plates. So essentially current travels through the plates, and on the surface of the plates, that's where you produce your hydrogen and oxygen gas. That's where electrolysis happens and splits the water molecules into their individual elements. So this generator can hold 11 cups of water about in the actual water component of the generator, in the main piece of the generator. I would take out the plates to show you guys what they look like. I probably will in another video. I just have the chemical mixture already in there, so I'm not going to take the plates out because I sealed the top already. So you can see up here at the top, this is a one-way check valve, and I'll zoom in on this. This essentially is a backfire arrestor, so just in case there was an explosion in the line or anywhere in the generator, it would stop here before, or anywhere in the line going to the generator, or from the generator, sorry. It would stop here before entering this. This is where a majority of hydrogen gas would be contained when you're producing it. There's about that much space that would be for gas, and if there was a flame to get in there, it would be a pretty nasty explosion, which you wouldn't want to happen. Alright, so here's a close-up of the check valve. You can see here's the output of the hydrogen and oxygen gas, which comes through one-way check valve and continues on to the spark arrestor. Alright, so this right here, this is the spark arrestor, and this is what prevents, if there was a flashback, prevents that explosion from coming up into the generator. This is essentially just a tube filled with water, and when the generator's on, it comes through, and the hydrogen and oxygen gas, the HHO gas, bubbles up through here. So I've seen in other videos it's called the bubbler or whatever. I just call it a spark arrestor, just because that's essentially what it does. It protects the generator from a dangerous flashback. So once you get the generator fired up, the bubbles will come up through here, and then they exit through this the top port here into the line. Here's a close-up of the individual plates inside the generator. These are all made out of stainless steel. I think they're about 1/16 of an inch thick, and the reason you use stainless steel is because of the anti-corrosion properties stainless steel has. It'll ensure the long life of the generator without the plates eroding away and corroding away. If you were to use any other, like if you use normal steel in this, it just wouldn't work. It would work for a little bit, and then the plates would start to deteriorate and fall apart, which you don't want. So I got these cut for me I got a bunch of plates cut to the size I want, and then a bunch of smaller plates, and then I drilled the holes through them and put a nylon rod. There's one nylon rod right through here, and there's one up here that you can't see. It's a little bit out of sight. The bottom of this PVC fitting here covers that up. So, and to power the generator, it uses 12 volts DC, and I haven't done really an amperage test. I know this thing can draw at least 30 amps when it really gets going. The only problem I have with my generator, and with all wet cell generators, are you get current bleed off or leakage, which is all these edges to the generator. You get current bleed off, which produces a ton of heat. So this thing gets extremely hot really fast, which is also somewhat dangerous to the operation of the generator. It can slow that also breaks down the generator and decreases its lifetime. But that's the only that's one of some of the drawbacks to the wet cell. That's why my next one's probably going to be a dry cell that I'm going to try to test and see how it goes. So here are the two clamping posts for the positive and negative lines to the generator, and then these just run down into the generator, and there's two little plates there that connect to the positive and negative plates on the whole plate arrangement, and that's essentially how you power the generator. And then to ensure there's no leaks, there's silicone around these nuts. When this is a permanent setup. You can't remove these nuts anymore. You could, but it would ruin that seal. So, but otherwise you get leakage, and if you were to light a match or whatever nearby, it could ignite the gas and cause an explosion in the generator, which you don't want. So, alright, that's about it for this video, the HHO generator. I will have a later video sometime in the future on the generator in operation, and if you have any questions about the generator, how I built it or whatever, you can put it in the comments below, and I'll try to answer you as quickly as possible. So that's about it. Please rate, comment, and subscribe on this video, and I will see you guys next video.